Hello, so we're here at the 2019 Orthopedic Research Society annual meeting in Austin, Texas. My name is Ronald Kwon. I'm an associate professor at University of Washington Department of Orthopedics and member of the Institute for Stem Cell and Regenerative Medicine. Our lab studies the genetics of bone disease and regeneration using zebrafish as a model system. And I'm very excited to have with us here Ms. Tonia. Welcome, Tonia. Nice to meet you.
Nice to meet you.
Could you tell us a little bit about your background?
Sure. So I'm currently a fourth-year graduate student in Rob Moxab at the University of Pennsylvania, more broadly in McKay Orthopedic Research Center. I did my undergrad in BE at MIT and worked for a couple of years before starting grad school at Penn, also in BE.
Oh, neat.
Yeah.
So how did you get interested in scientific research?
Oh, science research broadly. Actually, I kind of cheated. My parents are both scientists, and they're in research. So I actually didn't know any other type of life, to be honest. I didn't think twice about it.
Yeah, yeah, that's great. What brings you here to ORS?
So here I'm presenting the work that I've been doing for the past year and a half for my thesis. I'm kind of really interested in studying how our joints develop as a whole. So a lot of people here want to know how they work and how they break when we get older, but I'm really curious to see how they form in the first place. So that's sort of my research topic.
Okay, so what specifically is your abstract about?
Sure. So within the knee joint, I'm really interested in the meniscus, which is this also fibrous load-bearing tissue, much like tendons, ligaments, etc. And the purpose of my work is really carefully tracking the development of the knee joint from its conception basically to when you have recognizable tissue, and seeing what the cells do, how they self-organize, and what events precede what other events in terms of building a timeline for tissue formation. I'm also very interested in seeing how mechanics play into cell phenotype, and so development is this really robust process where things happen very quickly on the cellular and microenvironmental level. So in general, I'm very curious to see what the interplay between those two systems are.
Yeah, absolutely. So for some of our members who are not scientists, so what is sort of what is the long-term goal of your research, and how is what you did for ORS going to help you?
So the long-term goal, I guess, of my research is bridging two fields that right now are kind of separate. So there are a lot of people who use in vitro systems, sort of cells in a dish, to study how mechanical cues and forces influence cell behavior, essentially. But they always motivate that work with things that can happen in vivo. And so what I want to do is actually study a tissue context and see what some of the published data so far that has been done in a dish, which parts of it apply to actually in vivo models.
Yeah, great. So you said that you're second year?
I'm a fourth year.
Fourth year, great.
Yeah.
So you're going to be graduating soon, hopefully.
Yeah.
So what are your plans?
So it's a point of contention right now. I'm not sure if I want to follow the traditional academic path. Rob knows, so my advisor knows. But I don't entirely know what that entails, so I'm actually part of the mentorship program through ORS to try to talk to people and gather advice from everyone in sort of the ORS community to see how they got to where they are and how that can help shape the next step in my life.
Yeah, that's great.
Yeah.
All right, great. Well, I've seen your work, and based on the quality of the work, I'm sure that we're going to be hearing many things from you in the future. So
thank you so much.
Thanks for taking the time.
Yeah,
it's great to meet you. And thank you, couple.
Thanks.